Trees are harvested under strict control. Contaminated or damaged wood is rejected immediately. Once cut, logs move directly to pulping facilities. Exposure time is minimized to reduce contamination risk. This is where raw wood becomes usable fiber. Hygiene control starts before processing even begins. Bark carries dirt and microbes. Removing it is the first hygiene barrier. Only clean, uniform chips are allowed forward. Everything else is discarded.
From here, the fiber is protected. Once pulping begins, contamination cannot be removed.
Clean wood chips are fed into the pulping system. From this point on, fiber cleanliness must be maintained chemically, not manually. These digesters use heat, pressure, and chemicals to break wood into individual cellulose fibers.
The chemicals dissolve lignin, the natural glue in wood. What remains is clean, flexible fiber.
If temperature or pressure drifts, fibers are damaged. Once broken, fiber strength cannot be restored.
From here, exposure is not allowed. Any contamination would spread through kilometers of paper. Before paper can be formed, this pulp must be cleaned completely. There is no later opportunity to fix hygiene.
Washing removes chemical residue left from pulping. If contaminants remain here, they will travel through the entire factory.
Fresh water moves against the pulp flow, pulling impurities away instead of pushing them deeper.
This stream carries dissolved chemicals and biological residue out of the process permanently.
Bleaching here is not cosmetic. It neutralizes biological risk and stabilizes fiber chemistry. Time and concentration are tightly controlled. Too little leaves contamination. Too much weakens the fiber. At this point, the pulp is hygienically clean. From here on, contamination prevention becomes the priority.
Once cleaned, the pulp enters refining. From here on, fiber structure is shaped, not cleaned.
Refiners apply controlled mechanical force to the fibers, changing how they bond together. This process roughens fiber surfaces slightly, increasing softness without sacrificing strength. Too much refining weakens paper. Too little makes it harsh. Balance here defines product quality. Water content is adjusted to exact levels. This consistency controls how evenly sheets will form later. If consistency drifts here, sheet formation will fail across the entire machine.
With refining complete, the pulp is ready to become paper. From this point on, hygiene risk increases.
This is the most sensitive area in the factory. Once sheets form, contamination cannot be removed.
Highly diluted pulp spreads across the forming wire. Fiber distribution here determines sheet uniformity. As water drains, fibers lock together. This happens at extreme speed. Once bonded, the sheet becomes a continuous surface. Any airborne particle becomes permanent. Airflow is filtered and controlled. Even dust would contaminate kilometers of paper. Early defects are detected immediately. Once the sheet moves forward, correction is impossible. From here, the sheet must stay intact and clean. Pressing will lock its structure permanently.
After forming, the sheet still contains large amounts of water. Pressing begins the final structural phase. These rollers squeeze water out mechanically. Uneven pressure here weakens the sheet permanently. Removed water is immediately separated. Allowing it to return would contaminate the paper surface. Drying uses heat to remove remaining moisture. This step fixes the sheet's final strength. Moisture evaporates under controlled heat. Overdrying creates dust. Underdrying allows. Once dry, the sheet cannot be cleaned or reshaped. Hygiene is now permanently locked.
With structure fixed, the paper is ready for softness control. Any contamination from here on is final.
After drying, the paper is structurally stable. Embossing now shapes how it feels, not how it holds together.
These rollers carry precise patterns. Any contamination on their surface would transfer instantly to the paper. Pressure creates air pockets that improve softness and absorption without tearing the sheet.
This texture is permanent. Any defect here repeats across kilometers of paper.
Because the surface is exposed, this area is tightly isolated. Hygiene. After embossing, the paper remains exposed. Winding concentrates everything into a single continuous roll.
The core must be perfectly aligned. Any error here damages kilometers of paper instantly. Uniform tension prevents wrinkles and tearing. Once wound, defects cannot be isolated. Tension is constantly adjusted. Small deviations here multiply across the entire roll.
A single jumbo roll holds kilometers of finished paper. One contamination ruins it all.
Once complete, the roll is sealed immediately to prevent exposure.
From here, one roll becomes thousands. Hygiene mistakes now scale instantly.
The sealed jumbo roll enters slitting. From one roll, thousands of consumer rolls will be created.
These blades define roll width. Any contamination here spreads across every finished roll. The jumbo roll is cut into multiple narrow sheets at once. There is no tolerance for edge damage. Each strip rewinds onto a core. Tension here determines how the roll performs in use. If tension drifts, rolls collapse or tear later. Errors here are invisible at first.
Each finished roll looks identical, but its quality depends on every step before this.
From this point on, the paper is fully formed. What remains is verification and sealing.
The core may look simple, but it must be clean and dry. Any contamination here transfers directly to the roll.
Cores are inserted automatically. Human handling is avoided to reduce contamination risk.
Correct alignment ensures smooth tearing and stable storage during transport.
Tension is fine-tuned here. Too tight damages sheets. Too loose causes collapse.
Clean edges reduce dust. Excess fiber would compromise hygiene and packaging.
This is the last chance to catch physical defects before sealing. Once rolls leave this stage, only testing stands between them and packaging.
Every roll is scanned for shape, edge damage, and surface defects that indicate upstream failure. Weight and density confirm correct winding and tension. Errors here mean internal damage.
Rejected rolls are removed immediately. Once identified, they cannot be corrected.
Random samples are taken for deeper testing under controlled laboratory conditions.
Excess fiber dust signals over-drying or damage. This directly affects hygiene during use. Cleanliness tests confirm that no biological contamination survived the process. And only fully approved rolls are allowed to continue. Everything else is destroyed.
Packaging is not decoration. It is the final hygiene barrier between the factory and the consumer. Each roll is sealed immediately to prevent airborne contamination.
Bundles are formed without exposing the paper surface again.
Once sealed, the product cannot be cleaned or reopened without loss. Boxes protect the seal during transport and storage.
Boxes protect the seal during transport and storage.
From here, the product remains sealed until the moment of use.
Once packaged, hygiene depends entirely on controlled storage and handling.
Temperature and humidity are regulated to protect the sealed product.
Damaged packaging is rejected before it ever leaves the facility.
Pallet wrapping adds another barrier against moisture and dust.
Exposure during loading is minimized to protect the seal.
Transport vehicles are selected for cleanliness and environmental control.
From here, the factory's responsibility ends only when the seal reaches the consumer.